quick blurb on LU decomposition, solving equations using LU decomposition. The decomposition into LU is very simple, and we've been over that, and that's been thoroughly covered. So we're not going to talk about how to decompose a matrix A, so that the equation AX equals B becomes LUX equals B. And we're not going to talk about why X is therefore equal to U inverse L inverse times B. Review everything that we've done, and I think everybody pretty well understands this anyway. Okay? But what we need to do is understand how you then solve this equation in the efficient manner. Of course, you can find L inverse and U inverse and multiply them in turn by B, but that would totally defeat the purpose of this. It'd be more work than just finding the inverse of A and multiplying it by B. Okay, so what do? Well, let's just look at this. X equals U inverse times L inverse B. Now, L inverse B is itself a column matrix. So let's call that column matrix Y. So Y is L inverse B. Okay, well, we solve this equation for Y, and then we can replace L inverse B with our solution. Okay, so this Y goes here once we solve this. And then we solve X equals U inverse Y. And then we solve this and we have our X. Now, let's observe how do we solve Y equals L inverse B without finding the inverse of L and multiplying it by B? Well, L, remember, is a lower triangular matrix. So that Y equals L inverse B, being the same as Ly equals B, is extremely easy to solve for Y using forward substitution, as we've seen. Okay? In other words, if you write out this equation as a system, you're going to have your first equation is going to be like x1 and a bunch of zeros is equal to whatever the first element of B is. Okay, so you're going to know x1, then you plug that in for x1. Your second equation will have an x1 and an x2 term and a bunch of zeros. You'll know the x1 term, you'll be able to solve for x2 and so forth. And I'm just waving my hands over that, but we've seen that. And that's a very straightforward process that is easy to understand. Okay, so this is solvable by forward substitution. We don't bother trying to invert L. We just put it into this form, write out the equations if necessary, and use forward substitution. Okay, then, of course, X will be U inverse Y. And we will have Y, it's going to be our solution that we get by forward substitution. And we do the same thing here. Now this is an upper triangular matrix times Y. So our last row will have like x10 equals some number. And then we back substitute that into the next last row, which will have like x9 and x10, so we can solve for x9 and so forth. So all I'm saying here is that then this equation will be solvable by backward substitution. So you solve this equation in 2 steps by doing a backward substitution on this, which is equivalent to this, and then a backward substitution on this, which is equivalent to this. That's a little bit tricky. So you really have to do a couple before you really fully get the idea. It's a very useful type of a strategy.